All right, the first one, it says, based on the pattern, what are the next two terms? You are adding or, you're not adding or, you're adding what?
3.
5, 6.
16.
Are y'all the same paper?
You're adding
Okay,
6.
you're adding 6 every time. So what's 27 plus 6? 33. And then what's 33 plus 6?
39.
There it is. So your answer is D. Okay, everybody good with that? Alright, next one. This one it says, what conjecture can you make about the 10th figure? So what do y'all think is going to be the 10th
The
one?
light one.
Well, I know this is going to be the 9th because of what? 3, 6, 9. So what's the 10th one going to be? That one. You can draw a picture, you can count, but what if it asks for the 50th or something? Sometimes it's easier to get your pattern.
Can I also circle the word in the front?
Yeah, that's right. Yeah. It's or you can draw it. You could have put that. Ooh. Okay? Whatever. Alright, then number 3. I'm gonna kind of fly through these.
D?
Number 3.
Did you say D?
I said number 3. So what conjecture can you make about the first 40 positive even numbers? Follow your pattern. This one's nice because it shows you the pattern. If it's just one number, it was 1 times 2. If it was 2 numbers, it was what? 2 times 3. If it was 3 numbers, it was what?
3 times
3
4.
times 4. If it was 40 numbers, it would be what?
40 times 41.
There you go. Okay, which is C. Alright, you're just looking for your pattern. Don't y'all know that we've done, it's like the 3rd or 4th time we've done that exact same problem. Okay? So this one says a counterexample is what you're trying to find. That means you're trying to prove it wrong. So it says any number that's divisible by 4, it has to be divisible by 4, is also divisible by 8. So we're looking for the opposite. It's not going to be divisible by 8. Is this divisible by 4 and 8?
Yes.
So that's not it. Is that divisible by 4
Yes.
and 8? Yeah. Is that divisible by 4 and 8?
No.
It's divisible by 4, but not 8. Why does that one not even work?
Because 8 times 2 is 16 and you can't get any higher than that.
Well, what about, what's the first thing say it has to be?
Divisible by 4.
Is that divisible by 4? So you can't even consider it. These were all divisible by 4, but that's the one that was not divisible by 8. Does everybody understand the counterexample? You're just proving it wrong. Okay. Let's keep going. Number 5. Number 5 says, what is the conclusion of the following conditional? A number, where am I? Oh, up there. A number is divisible by 3 if, okay, that's when I know this one's a trick. When it starts with the word if, it's easy to see. I'm going to underline my hypothesis real quick. My hypothesis is what comes after the word if. So if the sum of the digits of the number is divisible by 3, what's my conclusion?
And the number is divisible by 3.
The number is divisible by 3.
Which is
Okay.
D.
Which is what? No. D is a whole statement. All they want's the conclusion. What did you say the conclusion was? A number is divisible by 3. Oh, he said B? I'm sorry.
I said B.
Huh?
I said B.
You said D? Oh, it's B. The number is divisible by 3. It only wants the conclusion, not the whole statement. Okay? It was B. All right?
Can we think of that as like if it says it twice, then what's the conclusion? Because I'm confused how to find it.
You're what?
Like, can we say because it says it twice that is the conclusion since it like states it twice?
States it twice where?
Like the number is divisible by 3.
Well, this one, no, because that wouldn't matter. I don't know why it says the same thing twice. Because it says if the sum is divisible by 3. That one's the hypothesis. The conclusion is that then the number is divisible by 3. So, like if you did, I'm trying to think, 12, what's 1 plus 2 and 12? 3, so it's divisible by 3. Like that's what that first part, it's not really even saying the same thing. That one's talking about the sum. So your answer on that one is B. Alright, Number 6. Are y'all warm in here yet?
Yeah, it is a little warm.
I'll turn that on for just a second. Okay. I won't turn it on too cold of a temperature. All right, number 6. What's the hypothesis? Be careful on this. This is the hypothesis after the word if. This is the conclusion after the word
You want to
if.
underline if you want to put H and C.
Well, I need to know what words are the hypothesis. Because if you just put H and C, I'm assuming that you're including the words if and then. Okay? Does everybody understand that? Because that's a big deal. Because we've learned that over and over again. You cannot include the words if and then. Okay. Write this statement in if-then form. All triangles have 3 sides. So, the first part would be if it's a triangle, then what? Then it has 3 sides.
D.
So I'm looking for one that looks something like if it's a triangle and it has 3 sides. You're right, it's D. Okay? Is everybody good with that? Number 8. Is this statement true, or well, for this conditional statement, write the converse. What's the first thing you're going to do? You've got to answer that part of the question. You're going to write, if x squared equals 49, then x equals 7. That's the converse. I did that part, check. Is that true? If x squared equals 49, x has to be 7. That's the only number it can be. No,
-7.
that's not true. X could also be -7. So you put false. And then x equals -7.
Didn't have to tell you
It doesn't ask for it. I can't.
asked everybody.
I made it on that, one of the quiz, it was multiple choice and it didn't say why, it just said false. But if it asks for a counter example, give a counter example. I don't know if that one does. Oh no, you would just put false, you didn't have to state why. Okay, number 9. How many pages is this? That's a lot of problems. We're doing good. Number 9. It says, what's the converse of this? What do you do for the converse? You switch it. So I think that air's gonna come on, y'all. Are y'all feeling anything?
Not really.
I feel
It.
right there. I think you need
All right, maybe it'll come on now. All right. So the converse, you flip it. So I'm gonna say, if the coordinates are negative, then it's in the 4th quadrant. So where can I find one that says if the coordinates are negative, then it's in the 4th quadrant? And that is D. I don't think I see my whole paper. There it is. Okay. If the coordinates of the point are negative, then it's in the 4th quadrant. That is D. Is everybody okay with that one? I'm hoping that these are simple. I don't know.
How
They
many
may
times
be
the proof?
We're getting there. We're getting there.
Proofs are what
Some
kills
of
me.
these are simple and then other ones are not.
I'll tell you, it's the same things over and over though. It is. It's going to be the same type of questions. I'll tell you which ones to study tonight in a minute. When a conditional and its converse are true, you can combine them as a
Biconditional.
biconditional, true biconditional.
If and only if.
It's an if and only if statement. Very good. All right. Determine if both of these statements right here are true. If they are, write them as a biconditional. If they're not, put false. So if an angle is a right angle, it's 90. Is that right?
No.
If the angle is, it is. A right angle is 90 degrees. If it's a 90-degree angle, is it a right angle? Yes. So can you write that? You would say true. Both are true. So now, I think that's what C and D are saying. Now how do we write it as a biconditional?
An angle is a right angle if and only if its measure is 90.
There you go.
C.
It's C. See, D put the word not in there. It threw extra words in there. It's not that. It's C. Is this helping you, Emma? Okay, good.
C was 11.
11 is C, yes. Number 12. We had this one on the quiz. Hint, hint, Emma. So, write the 2 conditional statements that make up the following biconditional. So, we got to write 2 if-then statements. So, let me take this out and let's write if what? If
I drink juice,
I drink juice,
then it is breakfast time.
then it is breakfast time. Is everybody okay with that one? That's one of them. It said right 2. What's my other one gonna be?
If it is breakfast time, then I drink juice.
Yeah, you just switch it around, boys. Y'all getting that?
This one.
If it is breakfast time,
Then I drink juice.
then I drink juice.
See, I'm on
We
top
did this
of it.
for my last 2 was. Maybe not.
Hey, we're just trash. You should make
No.
ourselves. Just go ahead. Everybody thinks that.
Is this statement a good definition? If not, give me an example, a counterexample. A square is a figure with 2 pairs of parallel sides and 4 right angles. It's not, because you're missing that they're all the same, right? The same. So, a rectangle. So you would say no, a rectangle.
Yeah, I got that one exactly.
Okay? One way to know that a statement is not a good definition is to find a,
Counterexample.
what did we just do on the problem?
This one
before?
was
Found a
last
counterexample.
Penis. A counterexample. We found a counterexample. So that's how you know it's not a good definition. Alright, are we good so far?
Yes.
Okay. Let's keep moving. Okay, the law of detachment and then syllogism. The law of detachment, these 2 things have to match, so then I can write this part. If 2 angles are complementary, their sum is 90. E and F are complementary. What do I know about it then? Their sum is 90. So which one of those show that E and F adds to 90?
D.
D. That's what I'm looking for, okay? If the 2 angles are complementary, then they measure 90. E and F are complementary, their measures add to 90. Okay, that is D.
So like if the last one matches,
If the front piece, if the hypothesis matches, then you can say that about it, okay? So this matches because it's talking about 2 angles are complementary. These 2 angles are complementary. It matches. So then I'm going to say those 2 angles add to 90s. Okay, you just write the conclusion from right there. Okay, the law of syllogism, it looks for the 2, I want to call them the middle pieces to match. This one and this one have to match. Do y'all think of that as being the whole 2 middle pieces? I don't know how y'all think of it. That's how I think. You have a healthy body, you have a healthy body. They match, right? So what can I say? It says, use the law of syllogism to draw a conclusion from the 2 given statements. If you exercise regularly, then you have more energy. So that's your answer.
But if you don't break it, then
So, well, all you're saying is what you know from this. If you exercise regularly, then you have more energy.
you didn't get my joke.
I guess I didn't. So what answer is that?
D.
D. I'm gonna,
I need big one.
what number are we on? Okay. Oh, I'm looking at the wrong thing.
Actually, really closer to
Actually,
Okay. Number 17. This one uses both the law of detachment and the law of syllogism. This is the same on your worksheet, Emma. A bunch of these have been the exact same questions. So, use the law of detachment and syllogism. So, if an elephant weighs more than 2,000 pounds, then it weighs more than Jill's car. If something weighs more than Jill's car, it's too heavy for the bridge. The elephant is 2,150 pounds. What can you conclude about the elephant? It gave you the first part, so you don't write that. So, Smiley the elephant weighs 2,150 pounds. So, what can you say? 2,150. Okay, so what can you say about it?
He's too heavy.
He's too heavy for the bridge. It's just, it's A. Okay?
A.
You're not gonna say C. Okay, it's not C. It's not asking, if they give you this front part, what can you conclude? This doesn't say if Smiley weighs that. It says Smiley weighs that. So what can you conclude? He's too heavy. Alright? It's telling you he weighs that, not if he weighs it. Alright, now let's do some algebra. Number 18. Or no, this isn't algebra, this is a proof. It says, what's the value of x? Oh, and then they just want us to say the missing parts. Do you see anything that says given, y'all? No, so you don't write given. If they don't give you any information, you can't write given. I don't see anything that says given. What do I know about adding two angles? What's that called?
Angle addition
It's
postulate.
angle addition. You can put postulate, or well, I see that they've got that down there. Angle addition, postulate. Okay, Cannon. Then they tell you the next one. That's great. Instead of writing the angles, they substitute in what the angles are, and then they combine like terms. They use the word simplify. That's the same. You can say either one. Simplify, combine like terms. They put that there. What did they do from here to here? What happened to that 12?
They've added it.
They added it. So that's additive, addition property of equality. Okay? And then they divide it. So you can pick your answer choice. Is everybody okay with that one? You're just saying, what'd you do to get from one step to the next? Normally we write given, but they didn't give us anything, so that's not given.
So that one.
We don't even have a protractor postulate, so. That one was what?
B.
It was B?
Mhm.
Oh yeah, sorry, I see. I can't see the whole thing up there. All right, number 19. So you have that BD bisects this angle. All right, so might be a good idea to draw this. So I've got angle ABC. And if BD bisects it, what does that mean? Cuts it into two equal parts, splits it in half. So if this one was 30x plus 36, what's the other one?
3x plus 3.
Also 3x plus 36. I don't know what I said. 3x plus 36. Okay. What's the whole thing? What does it tell me that whole thing is? 7x. It's right here. The whole ABC is 7x. So what can I do to find the missing angle? Well, this is angle addition postulate, right? I can do what with these two pieces? I can add them together and they will be the whole thing, 7x. Well, what is 3x plus 3x?
76.
And what is 36 plus 36?
72.
72. And if I add those together, they equal 7x. Is everybody okay with that? That's just angle addition postulate.
Are you good with this?
All right? Then what do I do?
Subtract.
Subtract what?
72.
6x. Yep, let's move the 6x over here. Move our 6x. So x is 72. Is that what it asked for? Because that's an answer. Is that what it asked me for?
Yes.
It didn't say find x. What did it say?
DBC.
Find this angle. How do I find that angle?
Plug and play.
Plug it in. What is 3 times 72 plus 36? Right here. 3 times 72 plus 36. It's actually,
252.
it doesn't even, this problem doesn't even make sense, but that's fine. We're good.
It's stupid.
Well, if that one was 252 and the other one was 252, that's over a circle. So this problem, it doesn't even make sense.
It's gay.
So, y'all have a
Likes
question?
men.
No. Okay. Keenan, are you getting all this? This one? Okay.
I'm gonna get A.
Everybody's good with this? Yeah? Alright. This one, what's transitive property? It says CD is congruent to EF.
Is it from
EF is congruent to GH. Then what do you know?
CD is congruent to GH.
CD is congruent to GH. That one is D. That's what you would know. Okay? It's transitive property. What is it when you flip them around and they're equal?
That's transparent. That's a substitution. That's true.
It's either symmetric, transitive, or reflexive.
Transitive.
Well, transitive is when you've got those, and then the others. This one is symmetric. It's symmetric when you just flip it around. That's symmetric property. That's just something you just have to memorize on that one. Okay? All right. Flying through.
Wait, so 21 is A?
21 is A.
Can you do something for me? Okay, dramatic.
All right, now, can I keep going?
Yes,
Okay. 22. This one, name the property. It says if angle A is congruent to B, angle B is congruent to C, then A is congruent to C. We already did that one, but what is that one again?
Transitive.
Transitive. Okay, so that one was A. 22 is A. 23, a 2-column proof. What I'll probably do is tell you, I don't remember how many proofs are on here, but I'll probably tell you how many there are. Remember, there's only 26 problems. And I'll tell you which ones. So, what is, do they give us something on this one? So what's my first thing probably going to be? Given. So let's just see. Does it match? It does. So I'm going to write given. Okay, then what do I do? What did they do from here to here? They replaced the X. What do we call that? Substitution. Kenan, what is wrong with y'all? When your mom asks, why did Kenan not do so well on that test? I'm going to send them a video. Okay, so then what did we do from here to here? Well, let's see. I moved the 60. How did I move it? Added 60. If you need to write it, let's see. Oh, I would add 60. So that's addition property. Addition property. Are we okay with this so far, y'all?
Yes, ma'am.
All right. Then, what do I do from here to here? And they kind of show you. You divide by -6. So what is that property?
Division.
Division property. Abbreviation is just fine. Just make sure you don't put sub for substitution and subtraction, okay? Then, I don't know what they did on this last part. I probably wouldn't
I
put.
put symmetric. If they were switched.
Yeah, you could. I'll see what they put. I would probably just leave that one blank. Honestly, they put. Hold on. They did addition already. What number am I on? Oh, I'm looking at the wrong one.
Beg your pardon, Miss Amanda.
They put that addition and then division and then they did symmetric. So that's fine, or we wouldn't have to put that, okay, at all. I would never have done this last step. I would never have written my variable second. You know what I mean? Like this is how I would have left my answer. So
Can we just leave that?
you can leave that part blank, if that's on there. If you put symmetric, that is absolutely right. Okay, can I keep going?
Yes, ma'am.
All right. On this one, what do y'all remember about vertical angles?
They're equal.
They're equal. So on this one, I would just say 2x plus 24 equals 144. How do I solve?
Subtract 24.
Subtract 24.
Then divide 2x by 120.
So 2x equals 120.
Divide.
It was 60.
Divide by 2.
60.
And x is 60. They just wanted x. That's all they wanted. So always go back and make sure. If angle 2 is 30, I'm going to write that down. What's angle 4?
30.
30.
30. Because they're vertical angles. So I know it's 30. Okay? Everybody good with that? We are. That's okay. Number.
Are these proofs on this one? On this next page?
Are these all? I don't. Like number 26?
Yes, ma'am.
No, it'll say write the proof if it wants a proof.
Okay. Because I definitely did not do the next 6 of them.
Okay, if the following, or no, I'm sorry, not if. Is the following true or false? If it's true, explain why. If it's false, give a counterexample. So, is this true or false? If it is snowing in Dallas, Texas, then it is snowing in the United States. Is that true?
Yes, Texas in the United States.
And that's your reasoning. That's exactly what you would say. You would say this is true because Dallas is in the U.S. Okay? So you don't have to prove that wrong. That's all that one is. True.
Do we have to put Dallas or can we just put Texas?
You could put Texas. Okay. A plumber knows, or do y'all need a second to write that down?
Yes, ma'am.
Okay. A plumber knows that if you shut off the water at the main valve, it is safe to remove the sink faucet. The plumber turns the main valve to the off position. What conclusion can the plumber make?
It is safe to remove the sink faucet.
That it's safe to remove the sink faucet. So,
Cause the water's off.
well, but you're using this. If you shut off the water, it is safe to remove the sink faucet. The plumber shut off the water. What can you conclude? It's safe to remove the sink faucet. Okay? So that's the answer it's looking for. I think that was just on a worksheet. Okay. Write the converse. This one was already on here, but do I need to do this one again? Wasn't this one on here?
Man, I can't read mine.
Would it be if x squared equals 16?
Then x equals 4. Yeah, it would say if x squared equals 16, then x equals 4. I think we did one just like it. Okay, and then it's not true, right? This one says provide a counterexample. What would your counterexample be? X could equal what? -4. So you would say false, x equals -4.
This is not it.
So that one, it's similar to the other one. This one just asks for a counterexample.
What were you?
Okay, boys, y'all can mess up your own test, but don't be so distracting that you mess up somebody else's.
I do it.
Okay. Alright, use the law of detachment to draw a conclusion from these statements. If it's not possible, just put not possible and explain. If two lines intersect, then they are not parallel. The law of detachment says the first parts have to be the same. So it should say A, B, and C, D what?
They're not parallel.
Intersect. Look, you can't. This says if two lines intersect. What does this have to say? A, B, and C, D intersect. It has to say. So you would say not possible. Yeah, and you can say hypothesis doesn't match. Or you can say A, B, and C, D must intersect. Must intersect. Or the hypothesis doesn't match. Some type of explanation. Does everybody understand that? It's just using the law of detachment. I'm going to come back and do this other one because I need more room to write. What number is that I'm about to do? 30. I'm going to come back. I think 30 is on there. So I want to come back to do it. All right. I'm going to skip to 31. 31's fill in the blank. Okay. So on 31. Do you need me?
I was just checking on you.
Oh, are you sore? Me too. Goodness. I sent Joni a message this morning. I was like, I'm so sore. My arms, my legs.
Right here hurts really bad. I'm gonna fall. What'd you do? Nothing at all. What happens in the gym with teachers stays in the gym with teachers.
Hey,
Don't tell me
yo.
I'll fail.
That's why my hand can't.
I was just coming to check on you.
That's why my hand don't.
Got to make sure that I wasn't acting the boat broke along this morning.
What they do for basketball?
Not working.
I have arthritis. It's like skin every
This is offensive tutorial.
Okay, this one. It says, this is a paragraph proof, so they don't start with given. They do it a little bit different. We just fill in the blank on this. What does it mean to have supplementary angles? That they add to?
180.
So that's your first blank.
See, Miss Man, I've been paying attention.
Wait, are we not doing 31?
No, we are doing 31. I'm coming back to 30. In a sec. I didn't have enough room to write number 30, and that one takes a little bit of time. So we're skipping to 31. Is this not 31 for y'all?
It is 30.
Oh,
It is 30
I thought those were two
points,
different problems.
No, this is it. So, what does it say about angle 2 and angle 3? Since they're supplementary, they are also going to add the 180 because that's what was up here. It says there and there. Okay. So then I can say that measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3. What do they do with that? Some people would put transitive, some people would probably put what?
Substitution.
Substitution. Either one of those are kind of interchangeable a lot. I'm good either way. Let me see. I'll tell you what they put. I think they put substitution. This is 31. Oh, I didn't put anything right there. They put transitive or substitution. Okay, they put both actually. So I'm good either way. Transitive. Normally on that one I put substitution. They put either answer on there. Okay, they even say that. Now they're telling us, okay, subtract that from both sides. So what's left?
The measurement of angle is of angle 3.
Equals what? Oh, I'm sorry, measure angle 1 equals, you were saying measure angle 3. That's right. I misunderstood. Yep, you get that. Angle 1 is equal to measure angle 3. Is everybody okay with that? Then what does that mean? Instead of writing the measure as equal, another way to write that is,
Angle 3.
yeah, angle 1 is just congruent to angle 3. That's just another way to write it.
What was C? What was that?
This one is angle 3, and that is angle 3. This transitive or substitution, you can put either one. It's just saying if this equals this and this equals this, then these two things equal. So it sounds like transitive, or you can think, oh, they just replaced that right there, substitution. That's why it could be either one. Okay, so 180, 180. Angle 3, angle 3. Those are a bunch of our answers. Okay, almost done, y'all. Don't let me forget to come back. Did y'all need- Yeah, I'm going to come back to number 30 in a second.
Is it on our test?
I think it is. So, but I think I still have plenty of time, huh? Yeah, I've got time. So just don't let me forget to come back to it. All right. This is a 2-column proof. What's the first thing I'm going to write? Did they give me any information? They did, and they wrote it. So I'm going to write given. Everybody, if that one was on there, you should get 1 point for that already. Okay?
Like, you always write given on the first one?
If they have something that's given, and yeah, I mean, most of the time, there was a problem earlier.
You still give them with the I?
Yeah. Okay, then it says, okay, the measure, so angle 1 is congruent to angle 2, and the measure of angle 1 is 130. So the measure of angle 2 is 130. What do y'all want to call that?
Substitution.
This doesn't make sense.
I would put substitution. If you put transitive, I can see that as well. Okay? But I would just say, instead of writing angle 1 equals 130, I'm just going to substitute angle 2 in, since they're the same thing. So I'm going to write substitution on mine. So now, how do we know that angles 2 and 3 are congruent? Look at our picture.
They're vertical.
They're vertical. We already did a problem earlier. Vertical angles were congruent. So we're going to say vertical angles. So how can I say angle 3 is 130? If angle 2 is 130 and angle 2 equals equals angle 3, then angle 3 is 130. What's that called? Transitive. Or I think they put substitution again. Again, substitution and transitive can kind of be used. Is everybody okay with that one?
So transitive and substitution can be used.
They're very similar. Now, sometimes the answer has to be substitution. Like if they say 2x plus 3 equals 6, and x equals, or plus 3y equals 6, and x equals 1, and then the next thing you get is this, that is most definitely substitution. That is not transitive. Does that make sense? So if you substitute a number in, definitely
So you just look up
substitute.
at the top and then look up.
Yeah, you're using all this information, so sometimes you have to go back and forth to see what information, like when you get to angle 2 equals angle 3 and you're like, I don't know why, go back and look at your picture so you can see, because they gave you that picture for a reason. All right, number 33. It says for us to justify each step. So do they give us anything? There's nothing that says given, right? So canon, on this one, we don't write given. It doesn't say given anywhere. So what is this add-in segments probably going to be called?
Transitive.
Segment addition. remember angle addition, when I add angles, what are these though? Segments. So this is segment addition. Postulate, you don't have to put postulate. But I'm adding segments. What do I do from here to here? Very good. I replace the letters with these values. Okay, the AB, I replaced it. That is substitution.
What if you you plug it in? Would that be better?
What happened to abbreviate?
That one, it's gonna wanna be substitution though for that. What happened to I might abbreviate in a second. I'm gonna abbreviate on this next one, maybe. What did I do, and then on this one, what did I do with 2x and 6x?
Or combine.
Combine like terms.
Combine like terms, what's another word? Simplify. They probably put simplify, I normally put combine like terms. So either one's fine, simplify is shorter, so I wrote it. But I would combine like terms. It is not addition property, because I did not add the same thing on both sides. Addition property means you add on both sides. What did I do with that 8?
Subtraction.
Subtraction property. I did subtract 8 from both sides. So I'll abbreviate that. Subtraction property. Then my last step, what did I do? Divided by 8. So that's division property.
Are you gonna go through and say like we're gonna try to
Yes, I'm about to. And then I still have to do number 30. Do we have one left?
What did you get for C and D on 32?
subtraction property and then division property?
Thank you.
Wait, no, that one was for 33.
Oh.
32, the one before it. What did I get?
Vertical angles and transitive property?
Thank you. Does everybody have that? No, sorry. y'all.
I got it, Mrs. Man.
That was segment addition, if you were still writing at the top.
Dude, like, I just away from my head.
Is this bad, or are we doing okay? We're fine? I mean, this is horrible?
Yeah, the proof I'm gonna just write Mrs. Man, I don't know.
If you look at it, you'll do fine. The proofs don't change on the test. So
So I
there's
just-
only a couple. And I give you a freebie. Oh, yes,
Like, I don't know what the words mean.
That's just gonna take practice and staying locked in during class.
And locked in, Mrs. Man.
Mm-hmm. Okay.
My hands are locked in.
Okay. Angles 1 and 2 are complementary.
Feel that.
2 and 3 are complementary. So prove that. Let me see if. Hold on. Let me see something. Let me pause this for just a second. Here's the deal. There are a few proofs on the test, but remember, there's 26 problems. You only have to do 25. All right. So you can just pick one to not do. My recommendation is that you do them all, in case you can get, try to get as many of them right as you can, and then I'll just not count one against you. Sometimes people will do them all and they think that they were going to miss one and they actually got it and missed an easy one. So it's good to just try them all, okay, all 26. Now, that being said, there is a proof like this where it's no fill in the blank. Big hint. This one talks about complementary angles. There is a proof identical to this on the test that's fill in the blank, and it talks about supplementary angles. All you have to do is change the words. Like, you can flip back and forth. Does that make sense? So I could go, if this is on my test and it's talking about complementary, I'm like, I don't even know where to start. We'll go to this problem. Guess what it is? The same thing, except what word does it use?
Supplementary.
Supplementary. Okay? So you can flip back and forth and you can say supplementary angles. So
it doesn't have to be like the 2 columns?
it doesn't have to be. It didn't say it had. It doesn't say. It just says prove. So it doesn't say do a 2-column proof. If it does say, I don't care what kind of proof you do. Okay. So definition of complementary angles. I'll kind of do the paragraph proof. Angle 1 plus angle 2 canon equals 90, and what? Angle 2 plus angle 3 equals 90. Y'all, I copied that from the other proof. I mean, kind of. But instead of, we put 180 in the other proof. Why are we putting 90?
Because it's
Because it's complementary. Okay, is everybody good so far? Now you can flip back and see what's the next thing. What do? They put measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3 by what? What did we pick on the other one? Substitution or transitive property. I think I put transitive on the other one. I'll just put transitive here. Are y'all okay with that? Yes, no, maybe? No? All you're doing is saying, okay, those add to 90. Those add to 90. If they both add to 90, then they're the same thing. Then they're equal.
We're
Okay?
done.
That's transitive property. Huh?
We're done.
No. So then what did they do with these angle 2's from each side?
Now,
They took them out, they subtracted. So I think they put something like this. Subtract measure of angle 2 from each side. It's something like that. So what do we get? The measure of angle 1 equals the measure of angle 3. Then what? What are they looking for? So what am I gonna write next?
angle 1 equals angle 3.
So angle 1 is congruent to angle 3. It's something like that. It's whatever's written on that other page. All you're doing is copying from the other page. I'm gonna see what's on there. Oh, and I'm gonna look at number 30 too. Hold on.
Yeah, we're done.
Well, I still got number 30.
Dang it.
Here we go. Number 1. Number 2. 3. 4.
4.
5.
5.
6.
7.
10. What? Where is this one? Hold on, we might have to go backwards. Number 8. Sorry, yeah. Number 9. One of them just got a little out of order. Number 11. Number 12. 13. 15. 19. What was it? Okay. Going back again, 16 and 17. 23, 24, 26, going to 25, 27, 29, number 30, which I'm about to give y'all, and okay, here they are. 34, go back to 31 and 33. And that's 26 problems. Remember, you only have to do 25, okay? But you can do all 26. And I put those two proofs, one of them, like the paragraph proof I just did, they're back to back, I think. I'm not sure. All right, real quick, number 30. How much time do I have?
Not long.
Ooh, let me just give you your answer. I'll just show you the answer. Because there's the answer. Real quick, I'll go over it. Because I think I'm still videoing, yeah. So, number 30, the converse, remember you just flip it around. So, number 30, when I had the converse, it would have said, if a figure's a parallelogram, then it is a rectangle. And it's false. Okay?
Do you have to put white sauce?
I can't remember if it said, but I'll look and see.
Yeah,
I-
say
I-
good count everything.
Okay, I probably would just be fine without that. I just wanna know that y'all know the converse false.
I just don't think contrapositive.
Okay, the inverse, you keep them the same and you put the word not. So the inverse, if a figure's not a rectangle, it's not a parallelogram, it's false. Okay? And then the contrapositive, you do both of those things. You put the word not and you switch them around. If a figure's not a parallelogram, then it is not a rectangle. That one is true. And that's usually the pattern, false or true.
Here we go.
When the bell rings, let's just wait till the bell. I will pass back papers tomorrow, okay?